Okay, we're going to start with our previous example, which gives a function based on the variable x, which says -5 times x plus 12. Our first value says x is 4, which means we're going to go to the function. We're going to take -5 times x, which in this case is 4, and then add 12. -5 times 4 gives us -20, plus 12 gives us -8. On the next line, we have -2 being plugged in for x. Again, we're going to take our function. We're going to plug in -2. The same thing is going to happen here. It's going to multiply times that 5 and add 12. In this case, -5 times -2 gives us 10, plus 12 gives us our final value. The last row of our table is a little different though. Hopefully you'll notice that 27 is the f of x. It's in the right column, which means it is what has come out of the function. What that means is something went in to this function and the answer came out 27. This requires us to do some solving. I'm going to subtract 12 from both sides, giving me -5x equals 15. And then because the -5 is multiplying by the x, I'm going to divide by -5. My resulting equation then, x is by itself, 15 divided by 5 gave me the answer -3. This is what goes into our box here. And of course we can check this by plugging that -3 back into our function. -5 times -3 gives me 15, plus 12 does in fact give me that 27 that I'm looking for on the other side. So when I look at this table, which is very handy for displaying information, what I want you to understand is we could write this a different way. We could say, if we put the value 4 into our function, we would get -8 as an answer. That is, f of 4 equals -8. If we put -2 into the function, we get the answer 22. And if we put -3, we would get the answer 27. That is, f of -3 equals 27. Let's look at another example. The number of water birds in a certain area is a function of how many inches of rain the area got that year. What this is saying is the number of water birds is a function of how many inches of rain. What that means is that this is decided by this. Water birds depends on rain. When we write this, what we're looking for is function of something, because we know a function in its typical form is a function of x. And if we can see function of, we know what our x is. So whenever we see x, we know it's inches of rain. What is dependent on x is the number of water birds. So our first question asks us to interpret f of 25 equals 45. What we know is this function is based on inches of rain. So 25 is inches of rain. And that means 45 is our result. That's the number of water birds. Our answer here to interpret f of 25 equals 45 would be to say 25 inches of rain results in 45 water birds. So let's look at the next one. Interpret f of x equals 100. We know that whatever gets put in, x is inches of rain. We don't have a number here, but we still can see the result. So if this were a question, possibly this is asking us how many inches of rain this unknown number will result in 100 water birds. So we're always looking for a function of something so we can define our x, our dependent, and our independent variables. More on that later. Example 3. Dinah rescues abandoned animals. How many she can keep is a function of how many square feet of open space she has in her backyard. So if I was asked to interpret f of 40 equals 3, it's important for me to see what is a function of what. Here it says how many animals she can keep is a function of, and these are our key words here, how many square feet of open space she has. So whenever we see that x, we know it's going to be square feet of open space. That's what we plug in. So this says 40 square feet of open space gives her enough room to keep 3 abandoned animals.